In the previous video, we learned how to find the nearest neighbour with the nearest neighbour object. In this video, we're going to take a look at the use of K-nearest neighbours classifier, which finds the class to which an unknown point belongs to. The K-nearest neighbours is an algorithm that uses K-nearest neighbours in the training dataset to find the category of an unknown object. When we want to find the class to which an unknown point belongs to, we find the K-nearest neighbours and take a majority vote. Let's take a look at how to construct this. First, we need to create a Python file, and we name it nnclassification.py. Then we import these essential packages. We will use the data nnclassifier.txt file for the input data. Let's load this input data. The first two columns contain input data and the last column contains the labels. Hence, we separated them into X and Y as shown in the preceding code. Next, we visualize the input data, so here we insert the code to plot the input data. We iterate through all the data points and use the appropriate markers to separate classes. In order to build the classifier, we need to specify the number of nearest neighbours that we want to consider. Let's define this parameter. So here we give the number of neighbours as 10. Now, in order to visualize the boundaries, we need to define a grid and evaluate the classifier on that grid. Let's define the step size. So here we give the step size as 0.01. We're now ready to build the K-nearest neighbours classifier. Let's define this and train it. Next, we create a mesh to plot the boundaries, as you can see here. Let's evaluate the classifier output for all the points. Now let's plot it with this line of code. Now that we've plotted the colour mesh, let's overlay the training data points to see where they lie in relation to the boundaries. Now we can consider a test data point and see whether the classifier performs correctly. Let's define it and plot it. Next, we need to extract the K-nearest neighbours using this model. So here we did it. After this, we move ahead to plot the K-nearest neighbours and highlight them. Then we print the classifier output on the terminal. Now we go to the command prompt and run this code. Oops, I forgot the name of our data input file. So you see, this is what can happen with these lengthy names. So I go back to recall it. And again we come back to the command prompt to run our file. So now we can see the predicted output on the screen, and the first output figure depicts the description of input data points. Whereas this second output figure depicts the boundaries obtained using the K-nearest neighbours classifier. The third output figure depicts the location of the test data point. And the fourth output figure depicts the location of the 10 nearest neighbours. The K-nearest neighbours classifier stores all the available data points and classifies new data points based on a similarity metric. This similarity metric usually appears in the form of a distance function. This algorithm is a non-parametric technique, which means it doesn't need to find out any underlying parameters before formulation. All we need to do is select a value of k that works for us. Once we find out the K-nearest neighbours, we take a majority vote. A new data point is classified by this majority vote of the K-nearest neighbours. This data point is assigned to the class that is most common among its K-nearest neighbours. If we set the value of k to 1, then this simply becomes a case of a nearest neighbour classifier where we just assign the data point to the class of its nearest neighbour in the training dataset. You can learn more about it at this website. Awesome! In this video, we obtained the distribution of our input data points, and then we plotted the boundaries using K-nearest neighbours. Also, we obtained the locations of the test data points. In the next video, we'll see how to construct a K-nearest neighbours regressor in a similar way.